guys come from? I didn't even see you sitting there. What's up, guys? I am Mr. Spencer, another 5th grade teacher here at KAO. I have the absolute privilege of teaching an awesome homeroom called JCSU. So shout out to all of my JCSU students watching this video right now. And also special shout outs to each and every single one of you. Shout outs to CSUDH, shout outs to Bryn Mawr, and shout outs to Clark Atlanta University. Welcome, guys. All right, so this is actually our very first lesson together. Isn't that cool? Welcome. We got a lot more lessons in store, but I just want to say welcome to this virtual learning space, right? Last week we learned and we talked about multiplying 1 and 2 digit numbers, and then also towards the end of last week we learned how to find perimeter, and yesterday we practiced how to find area of 2-dimensional shapes. Today we're going to take that learning and that knowledge a step further and practice finding volume of 3-dimensional shapes. So we know how to find area with length and width. Now today we're going to add another dimension to make it 3D, right? So later on this week, we're going to learn how to use unit cubes to also help us find volume, but that'll be tomorrow. Today, again, we're going to focus on learning how to solve for volume in 3-dimensional figures. Okay? I know that might sound like a lot, but guess what? I'm going to break it down so that we can all understand it, okay? If you're ready to learn, let me hear you say, "Oh yeah." No, that was weak, Let's do it one more time. If you really ready to learn and got all the energy and you are mentally prepared, let me hear you say, "Oh yeah." That's right. All right, ladies and gentlemen, we're in for an awesome lesson today. All right, let's see what we got. All right, ladies and gentlemen, let's take a look at the example in front of us. All right, so here we have a figure made up of 3 different side lengths or 3 different dimensions. And when I say by dimensions is we see a side measure here, a side measure here, and a side measure here, right? 3 different side measures, okay? What I want to ask is, by looking at this figure, do we know automatically the name of the figure? Some of us may want to automatically call it a cube, right? But this is not exactly a cube. The special thing about a cube is that a cube has all of the same side lengths. Since all of these side lengths are not the same, then this figure is not a cube. All right? So let's take a look and identify some more of its sides. So here we see a 5, right? If this side is 5, then that means that the side opposite has to be 5 as well. So I'm going to put a 5 here. If this side is 4, then this side is 4. So we have 4, 4, 5, 5. If this length here is 6, then that means that this length here is 6 as well. I'm going to put a tiny 6. And so on and so forth, right? So by looking at this shape, I kind of see that it's made up of some rectangles. Yeah. So the base is a rectangle and the side is a rectangle. So I would call this figure a rectangular prism. Okay, so we've got our rectangular prism in front of us. The next step, what I want to do, I want to identify the 3 dimensions that make up this rectangular prism, right? So I'm going to choose a different color. our length. Our length tells us how long the figure side is. So if I'm looking at a flat surface, the length, I'm going to say the length is 5. The length is 5. The width of the flat surface, how wide, is going to be 4. We see this right here. So we have the length and the width, the length and the width, or how wide, is 4. And then the height. Height, this is a new dimension that we're working with. Notice how when we learned area, the formula for area was length times width. It was only those two dimensions. Now, working with three-dimensional figures, we now have a new dimension called height. Height tells us how tall the figure is actually going to be. How tall. So height tells us how tall. So just think about it in real life. If someone says, "What is your height?" They're asking you, how tall are you? From the bottom, from the floor, to the top of your head. How tall are you, right? So we can take the height of this figure is 6. Okay? So again, our length is 5. Our width is 4. And our height is 6. 5, 4, and 6. Okay? So, how do we find the volume of a three-dimensional figure? Similar to that of area, remember area formula, the formula for area was L, which is length, times W, which is width. The volume formula, however, is length times width times, what was the name of the new dimension that we learned? The name of the new dimension that we learned is height. So we have L times W times H. L times W times H, okay? So I have my L, I have my W, and I have my H. What operation am I going to use to find the volume? Is it going to be addition, subtraction, multiplication, or division? Addition, subtraction, multiplication, or division? Well, we've already answered that question, right? We said that times means to do what? If you said multiply, you are absolutely correct. We're going to multiply all three of these numbers. So we've got 5 times 4 times 6. 5 times 4 times 6. What does that equal? Looking at my setup, I have 5 times 4, which gives me 20. And now I have to multiply 20 times 6. 20 times 6. Remember last week we learned how to multiply double digits and single digits, or single digit numbers and 2-digit numbers, remember? So what I can do using the lesson from last week, I'm going to line it up. I've got 20 times 6, right? 6 times 0 gives me 0. And then 6 times 2 gives me 12. So 20 times 6 is 120. So my volume is equal to 120. Again, let's recap. We identified the side lengths, or we identified the dimensions of the figure. Dimensions of the figure, right? In other words, what are the different side lengths? Dimension answers that. What are the different side lengths? If it's a flat surface, right, we only have a length and a width. 2D. If it's a 3D surface, or a 3D figure like the one that we see in front of us, we have 3 dimensions: length, width, and height. Volume actually tells us how much space is being taken up inside of that figure. How much space is being taken up. So for volume, I'm going to put how much space is being taken up. In this case, we found out the length was 5, the width was 4, the height was 6, and if we multiplied all 3 of those dimensions together, we found that the volume was 120. Since we did such an amazing job finding the volume of the rectangular prism, let's try it one more time. Alright? Taking a look at the figure that we have in front of us, the first thing that I want us to do is I want us to take a look at the side measure or the side lengths. What do we notice is different about this figure in comparison to the first figure that we took a look at? What do you notice about the side lengths in this figure? That's right. All of the side lengths in the second figure are the same length. When we were looking at the prism before, what did we say that the name of this figure would be if all of the side lengths were the same? Do you remember? It starts with a C. It's a cube. That's right. It's a cube. Not ice cube, but a cube. That's right. So cubes are special 3D figures that have the exact same side lengths throughout the figure. So what this says, essentially, if this side is 7, this side is 7. If this side is 7, this side is 7. If this side is 7, this side is 7. And you automatically know that all of the side lengths are 7, no matter what. And that is what's special about a cube, okay? So looking at the cube, we want to find the volume of this cube. If we know that the side lengths are 7, no matter what, we automatically can identify the 3 different dimensions, or the 3 same dimensions in this case. So the length is 7. What do you think the width is going to be? 7. Alright, this is a trick question. If the length and the width are 7, what's the height going to be? That's right. 7 again. We got 7, 7, and 7. Taking a look at the bottom, our volume formula, we know from our previous example, is length times width times height. Here, we only have the option of 7, or the measure of 7. So my length is 7 times my width, my length, my width, and now times the height, how tall it is 7. So we got 7 times 7 times 7. Using our multiplication, or our times table, we know automatically that 7 times 7 is 49. Now I've got 49 times 7. All right? 49 times 7. I know some of us have already been doing the, trying the problem out in our head, But just to give us a visual model or a visual example of what that looks like, let's work through it together. So we got 49 times 7. Again, a 2-digit number times a 1-digit number. We're going to line it up and then multiply accordingly. So we got 7 times 9. 7 times 9 gives me 63. I'm going to place my 3 and carry my 6. I got 4 times 7. 4 times 7 gives me 28. And then 28 plus 6 gives me 34. So my answer is 343. Volume, or V, is equal to 343. And I'm going to circle it because I'm 100% confident that that answer is right. Excellent job, guys. All right, ladies and gentlemen, we can't end today's lesson without a recap. No cap, let's recap. All right? So, we have 3 major takeaways from today's lesson. 3 major takeaways. All right? Dimension. Again, when talking about volume, dimension tells us how many different side lengths exist within that figure. So for the first example, we had 6, 5, and 4. Those are our 3 different side lengths. And then for our second example, for our cube, our 3 different side lengths, or our length, width, and height, they all happen to be 7. Okay? So dimension tells us how many side lengths make up that one figure. And remember, for 2D or flat shapes that are just on your paper, right? Usually for squares and rectangles, that's going to be length and width. For rectangular prisms and cubes, however, for 3D or 3-dimensional models, that is going to be length, width, and height. Okay, let's take a look at that. 2-dimensional models only have a length and a width, squares and rectangles specifically. And 3D models, rectangular prisms and cubes, have a length, width, and height. Number 2, volume. Volume tells us how much space a figure takes up. How much space a figure takes up. And I want to show you a real world example, right? So here we have our spring bottle water. Our spring bottle water, if you take a look at any bottle of juice, of water, of soda, of coffee, the packaging will always tell you how much that physical bottle can hold, right? So this bottle, how they do on YouTube? This bottle holds 16.9 fluid ounces, or 500 milliliters of water. We're not going to go into the units, the fluid units just yet, okay? We're going to get on into that later on within our math class. But the concept that I want to show you is the amount of water that we have in this bottle, right? If I have my hydro flask here, my nice hydro flask, how we do on YouTube? If I have my nice hydro flask right here, right? I'm going to open it up. I'm going to put my cap down. Let's take a look. Do you think that the water from this bottle can fit inside of this hydro flask? Again, a question. Do you think that the water from this bottle can fit inside of this hydro flask? What do you think? Yes or no? Let's find out. So I'm going to take the water from here and I'm going to pour it in here.
Three days later.
Yes, it did fit. So the question what I want to ask you is why, or how do we know that that was going to fit, right? Some of us may have taken a guess. Some of us, or me in this case, I knew that the water from here was going to fit inside of here because the volume or the amount of water inside of this bottle is 500 milliliters. Remember I said that? 500 milliliters. The maximum capacity of this hydro flask I saw underneath it's 532, right? So since this hydro flask has a larger volume or a larger capacity, the bottle or the water inside of the bottle, the amount was smaller in here than it was in here. So think of this. If I'm an elephant, would I be able to fit inside of a punch buggy car or inside of a gymnasium? If I was an elephant, can I fit inside a tiny punch buggy car? Or can I fit inside of a gymnasium or a circus tent, right? I can fit inside the gym or the circus tent because the gym or the circus tent is larger than I actually am. So me being an elephant, although I have a large volume, the circus tent or the gymnasium has an even larger volume, all right? Something to think about. Last but not least, guys, area versus volume. Area is used for two-dimensional shapes, and volume, again, is used for three-dimensional shapes. All right, ladies and gentlemen, that's all the time you've got with me today. I hope that this lesson, this virtual lesson, really helped, and I look forward to seeing you again this week. All right? Again, please remember that with the virtual lessons, you can pause, you can rewind, you can fast forward at your own pace once you have access to the videos. But yeah, I'll catch you on the flip side again. Take care.